about this. I have an accident one of these days. Here I am driving, thinking about math. Not thinking about the person in front of me, where I could slam the brakes or whatever. Oh, I gotta be careful. Yeah, I was thinking about something a student asked about. They said, Professor, in fact, I saw on a few of the quizzes some students who were doing what I'm going to show you. So they've seen this somewhere. That would be this. If you're asked to solve this inequality. It looks like that. And you're asked to solve it. And I saw, like I said, I saw as I scored papers last night, 2 or 3 students doing a little bit of a different routine than I showed you on how to get that to work out. Guys, what I've shown you, let me do that part first. Of course, you remove that 4x or subtract 4x, and you're going to get that. Then I guess this is calling for what next? Based on what we've done in class, what would you try next? Factor out, and in this case, there's a common factor of x, so we're going to take the x out, and you got that. Now, I think on the quiz, if I'm not mistaken, I said show sign analysis. Did I? I said show sign analysis. So we did it this way. Many students on the quiz are good at sign analysis. My critical numbers, guys, just almost by mere observation are 0 and what? 4? And in this case, they're both open. We'll have more of these sign analysis types on the exam Friday. And you start testing. Now, when I say show all work, I want to see what number you tested. I want to see everything. Some students were messy. Some students are a little bit messy with their work. So if I ask, please show all work, and you're using sign analysis, I got to see it all here. I can't give you full credit. So out here, guys, -1 would be appropriate. Let's try 1 here, maybe a 5 here. And then, of course, we're going to replace by -1 here in the inequality, and look at the signs involved. X being replaced by -1, negative, of course. -1 subtract 4 is a -5, another negative. I wanted to see that. Some students, I realized that students knew what they were doing though. They just really quickly did this. And didn't show me it was a negative times a negative. I want to see everything. In between, we'll try 1. 1, of course, x being replaced by 1's positive. 1 subtract 4, it's going to be a -3. And yes, I realize that's a negative. Now to the right, let's try 5. Both, I think, are positive here. If I try 5, and I realize, you realize, you get that. Is that true, guys? Is that the way we approach the problems? And then you look at the result, and you're trying to answer this question here. When is this greater than, implying positive, greater than 0? Well, that's positive, I see, if you write this down here, from a negative infinity, looks like up to 0. Union, and it looks like this side is also positive, this interval. Looks like it's 4 through infinity. Is that true? And I'm happy. I have a smile on my face as I scored papers. I'm very happy. Now, some of my students are clever. They were doing something I had not quite shown you myself. They said, wait, Professor, you did mention a quadratic. Of course, this is a quadratic. You did mention yesterday that a quadratic should graph into a shape of a, or a curve known as a parabola. They're saying, and they did this for me, they graphed the parabola. I didn't ask you to do it that way, but they did this, which I love because it's coming up later. You say, wait, Professor, I'm going to approach this problem this way. I'm going to graph this parabola, the graph of this quadratic, x squared subtract 4x. And I have not shown you in class the techniques I want to graph a parabola. Does anyone have anything in mind there, based on what you see? How could I get a quick shape of the parabola that represents that quadratic? Even though I have not shown you any techniques, but I will later. But does anyone have an idea? Some of my students may have an idea because I think some of my students did it this way. Does anyone have an idea how to get the graph, the parabola, to represent this quadratic? Based on what you see on the board? I love this. I thought about this with free graph. Oh my goodness, I gotta make these two connect to each other. Yes?
It has to be up because quadratic is
Well, that is-
positive, A is positive.
Exactly. This leading coefficient is positive. It's positive 1. She says, Professor, I know for sure the parabola is going to open up. Now, if I say do a quick sketch, it's going to open up. Tell me more, though, a little bit more specific on this. What else may help? Yes?
You just plot where the zeros are.
Okay, look at this. And you use the word zeros. He said, wait, Professor, you've already discovered that the critical numbers here were 0 and 4. Right? He says, take those over. I'll do it like this, guys. And place those on the grid. What are the x-intercepts? And you found those in that little strategy of using sign analysis. Then I'm hearing, Professor, the parabola should open up. As God passed through 0 and 4, I have no choice. Is that the parabola? Look how easily done that was. Now, do I know this turning point down here? And by the way, does anyone recall what that point at the bottom here, in my case, the turning point was called on the parabola? I should have asked you guys that question when you walked in the first day. What was that little point down there where it turns? Down here. Vertex. I don't need the vertex to answer this question here. We'll find out how to find that vertex later on, probably today sometime. But that's the basic graph of this. This is here it is. Here's my quadratic, x squared subtract 4x with his help. Here's the basic graph. Now, my students did this. They said, wait, Professor, it says now to solve this inequality, you want that parabola to be greater than 0. That's going to tell me what would I look for on that red parabola if the question was, where is that parabola greater than 0? And I'll help you out a little bit more. When is that parabola above the x-axis? That's when it's greater than 0. And this inequality symbol says I want greater than 0. And my students, clever students, they did this for me. They said, Professor, this piece is above the x-axis. This piece is above the x-axis. Those are two pieces above the x-axis? That's what this says to find. Find the pieces that are above. If this were a less than symbol, you look for the piece below. Now, can anyone tell me an interval notation from left to right? Let's get this one out of the way first. What might that look like to express an interval notation? When is that happening? When is that on the left there that I just marked in blue? When is it happening? Give me an interval notation. When is this piece right here happening on the x-axis? I know it's going to stop at 0. Is it continuing on out this way? So can I write this as negative infinity up to my stopping point 0? Yes or no? This piece is also above the x-axis. That's what we want. Now, can anyone tell me an interval notation? When might that be existing out here? This piece. Now, notice we'll start forward. Does it go forever out to the right? Is it forward through infinity? Is that when the left and the right are above the x-axis? Did we get the same answer through sign analysis? Are these the two same answers? If I place a graph on the exam Friday, and I have the graph drawn for you, and I ask you, don't use sign analysis on this particular problem, I provide the graph, or I may ask you to graph it first. Do it by graphing. If I should have the graph, and you look at the graph there, and then you miss this, I am going to put a little face there, a little frowning, emoji type face. Say, what? The graph's I've got in front of you. Do you know what's above, what's below? That's my graphic for you. You can't miss this, can you? If this had been provided and you had known what's going on here, you could not have missed a problem like this. And some of my students were clever enough where they knew what was going on here. They did something like this. Even though I did ask you to do it by sound analysis. Guys, any questions there on what we could do here? No, just look at the graph. Now, with that said, though, part 2, I think I'm ready now to move into that handout. Let me check and see if I am. Hang on. Oh, I am. Now, I think I have 2 examples on the handout. I'm going to start out with, suppose you're asked to sketch, since I'm talking about graphs. Sketch this function, f of x is equal to, now here goes, to lead you into, that's section 1.4, I think it is. I'm not going to name the function like this. Like f of x equals x squared minus 4x, f of x, g of x, h of x. I'm going to list it in pieces. It's called piecewise defined function. I'm going to list the first piece, let me use different colors here. I'm calling the first piece x, and a constraint, restriction, it happens only when that's true. And the second piece, if this green marker will work for me, may not. Oh, it does. Negative x, if you meet this constraint, condition, x is less than 0. And many times in mathematics, we define functions as in pieces, rather than just a single expression like we're so accustomed to it. Guys, there it is. It's a piecewise function. It's when it has 2 pieces. I like to graph it. Now, since I have a variety of students in class, some students are telling me, Professor, it's been like 10 years since I've had math. Others will say, Professor, my goodness, I'm just fresh out of high school, or I've maybe taken a course here or there. I think I've had pre-calc just recently. Beautiful for you. I've got to be careful how I approach this. Does anyone, though, before I get into it, does anyone have an idea of what this will graph into? Oh, I see a hand going up already. Hang on just 1 second. Anyone else? I have not graphed it yet. Is Ramsey trying to play one here? Is this going to graph into this? No. That's what it has to have a graph. And I'll tell you ahead of time, it's not going to be a parabola. It's going to be in 2 pieces here. The one on the exam Friday, by the time we get to the exam, yours may have 4 pieces. I think the couple on the handout today have 3. So I'm going to be careful. Yes, let me get a response.
It will look like an absolute value.
Whoa! I'm here. Wait, Professor. Did we not see that V-shaped graph, absolute value graph, as one of the, I call them parent graphs? Did we see one of those yesterday, that V-shaped graph? The students tell me, Professor, this is that graph. Now, what on earth does that student see that we don't see? I haven't even graphed it yet. And I'm hearing, Professor, it's the V-shaped graph. It's the absolute value graph. In other words, if it is, I can say, are you kidding? This is equal to this. It's equal to absolute value of x. Now let's see if it is. Guys, we're doing it in pieces here. I'll do the red piece first. 1 piece at a time here. I'll be very, very cautious here. Now, for those of us who may have seen piecewise functions, some may not have seen piecewise functions, or maybe quite some time since you've seen one. Let me approach this carefully. Let's do the red one first. The red one says f of x is equal to x. But the condition is only if you use these types of x's. So if this will help, I might say let's use a table to satisfy that condition, and place in that table, like you did back probably in algebra 1, some numbers that satisfy this condition. They must be greater than or equal to 0. I'm going to start with 0. Maybe throw in a 1, maybe throw in a 2. You can try as many numbers as you wish, but those numbers in my table satisfy that constraint. They're greater than or equal to 0. And then go back and you're supposed to replace the x back here with those numbers to get the y. So if I start with 0 and take 0 back and put it in here, replace x by 0, you get this. And therefore you have an ordered pair. If I take 1 back, replace x by 1, you get 1. 2, take it back and replace it, you get 2. And I'll come back to it. I'm not going to come back to it. Let's get the red part done now on the grid. Okay, guys, I got 0, 1, 2. I'm going to plot points like we did back in Algebra 1, or maybe even earlier. 0, 0 should be right here, and can someone tell me why am I allowed to darken this in when I plot that first point, 0, 0? I see that equals mark there. The other points, 1, 1, all the other points definitely are going to be included. Okay, 1, 1, 2, 2, to do this, just to be looking nice. Okay, 1, up 1, 2, up 2. You can try 4 points. I'll connect those that I have, and in the red, in no time at all, we have a shape that looks like this. That's no issue, is it? No. Now see what the other one looks like. I have the other one in green. Well, if you want to do a table, if that is required, do it. And the constraints here says, yeah, let's start with 0 again. So I'll put a 0 in here. But this one says, now for the x values here in the constraint condition, it's going to be less than 0. We try -1, -2, not like that, and others. And you're meeting that constraint. Now where are you going to take those numbers? Of course, back to this. If I replace x by 0, I know it becomes a -0, which is 0. If I go back and put a -2 in, be careful, a -2, if I replace the x, it becomes a +2. A -1 gives me a 1. And those are my points I'll plot for the green one. Now when I go back to my grid, I'm going to start with 0, 0. Oh, you say, Professor, you've already darkened in 0, 0. That was from the red one. And this one says 0, 0 again. And therefore, it's already done for me. I can't reopen it, just darken in. A -2 up 2, absolutely, I'll do it. -2 up 2, the way I have mine would be here. And it looks like a -1 up 1 somewhere in here. And of course, guys, keep in mind, I will do this just to point out that green mark is right there. Connect, and you'll end up with the other piece of this piecewise function. So something like this. Now, please tell me, is that the V-shaped graph that we would expect for absolute value? I should have saved this for an extra credit problem for the exam Friday. I have a few extra credits on the exam. I should have saved this for the extra credit. I should have just said, just gave you this and say, what is this equivalent to? And then let you figure it out. And it's equivalent to this. And there's the graph. There's absolute value of x. Graph. With 2 pieces. Now, I wish all piecewise functions were this easy. They're not. Now, have I seen in all the math I've done, have I seen more than 3 pieces? My goodness, I've solved. I've seen up to 8, I think. 8 pieces. This one here, that one, this one here. And it still came up to be a function. By the way, guys, the vertical line test, will that still work here? So this is a function. Now, let me ask the student to read that first one to me. Did I use the function notation on it? Did I say f of x or g of x? Did I use that notation?
Yeah.
I did, didn't I? Did I say f of x on the handout? Or g of x? Okay, so it's a function. So this one, when I finish up, should pass the vertical line test. Now let's graph it. We solved this one here. I wish the others were as easy. Part 3, a sketch. And let's call this A, and I call this, Guys, make sure I'm reading the right one. Does it start out with f of x equals, the first piece is 2x plus 5? Is that it? F of x is equal to, it's like 2x plus 5. And if, here's the constraint, if this is true. I'll do that one in blue. Next one, if I'm looking at the right paper here on my desk, looks like it's merely -3 if x is equal to 0. I'll try green for the next one. Looks like it's x squared plus 1. And the constraint was if x is greater than 0. I can make sure I have everything written down correctly. You guys agree? Is that it? Now, I don't think any student would tell me without graphing what this one looks like. This one of my students quickly said, Professor, it's absolute value of x. I don't think you can tell here. We're going to actually go through each of those 3 pieces and see what this looks like. Guys, the first piece, before I jump into it, can anyone tell me, since I'm talking about pieces, it says 2x plus 5. Would that itself